Welcome. Thank you for coming today. I know it's kind of early, but let's try. Thanks for the introduction. My name is Luca Pellegrino, and the talk will be around red team engagement and mobile devices and mobile infrastructure is sort of overlooked, as we just said. Mandatory, who am I? I'm a penetration tester. I work at Dynac. I'm based in the UK. As part of my daily job, I basically do everything around pen testing. So external pen test, internal penetration test, web app pen testing, and more recently I've been involved in mobile application penetration test and red teaming engagement, which is basically the reason why I decided to make this talk. So what are we going to talk about today? Quick intro about red teaming, few concepts which I think are helpful. And then we're going to discuss why going after mobiles when we do these engagements, and then mobile applications from a pen tester perspective versus a red team perspective, which there are a few differences here. A bit of storytelling there. I want to propose some scenarios. These are like real-world engagements that we performed, where looking at the mobile infrastructure or mobile application was actually crucial for the success of these engagements. Finally, onto the technical bit. I'm going to basically discuss Frida, which ultimately, this is a mobile app presentation, so it wouldn't be complete without mentioning this awesome tool. But I'm going to look at Frida from a different angle. We use it mostly as a pen test toolkit, but let's have a look and see what we can do from an offensive perspective. And finally, I think we're going to have some time for some question and hopefully answer, if we can manage. Red teaming. I think everyone here is familiar with the concept. There was an awesome presentation yesterday as well around this topic. But essentially, during a red team, you want to replicate a real attack, a real scenario, or a specific threat actor as much as possible. It is an engagement, like a pen test, which is goal, trophy-oriented. So essentially, you have a goal in your engagement, being a SQL server on a restricted network, being the CEO or the CTO's mailbox, you name it. Typically, there are no restrictions in scope. So if you think of a pen test, you are limited on a mobile app, let's say, during a real engagement or red team engagement, essentially your scope is the organization, right? So you typically have little to no restriction, as I said. Finally, I want to stress this point. If you do a red team, it's most likely that you're going to face a blue team. That's the whole purpose of the engagement, right? So when you do a red team, we're all good hackers. We try to be stealthy. We reach our goal. We're cool. The client didn't expect us to succeed. We're super stealthy, as I said. But what about the blue team? Let's not forget about them. The reason why they're doing this is most likely because they want to test their defenses, right? So let's try to bring some value. So my suggestion is when you do a red team, you get in, you get your goal, but try to make some noise. I don't know, drop Mimikatz, whatever. Just make some noise inside the network. So you're kind of scaring them, but you want them to be awake. So there are a few phases in red team. Essentially, I group them in mainly 4 phases. You want to start, of course, with your recon, which is finding out as much as possible about your target, being their web app, what's available externally, essentially, and why not? If it's in scope, their physical office, if you're trying to break in, and then eventually you want to move into compromising or getting an initial foothold inside their network. That's mostly done through password spraying, and even though it's 2019, phishing still strong, you can just send a phishing campaign, and most likely you're going to get in. Once you're inside the network, you want to try and move laterally. So you want to essentially, from your perspective, what can you see? Can you get any passwords? That's going to be like an easy win. Can you get any PII? Personal information, right? Typically, we look for this stuff on file shares, right? Sort of related is escalation of privileges. Most likely, you're not going to get a domain admin shell after your phishing campaign. You're probably going to get like a receptionist shell or a low privilege most of the time. So you want to try and escalate. If you think about a pretty standard Windows Active Directory environment, that would be the equivalent of you going from a low privilege user to local admin, to domain admin, or eventually enterprise or forest admin, or whatever is the highest role in their network. So, okay, you're doing an engagement. Why you want to go after mobile phones or mobiles or mobile infrastructure in general? Well, as I said in the introduction, I've been involved in a number of mobile app pen tests recently, and I've noticed a general lack of mobile application hardening. What I mean is that essentially, across different applications, we always find the same issues over and over. And at the same time, though, for us, the testers, we're getting a lot better. There is a general improvement in testing methodologies. So those are like the framework that I've been using in the past years or so. And Drowser, Needle, Scrunger. We're talking about Frida, which is already a game changer in this field. But essentially what I'm trying to say here is that we're sort of winning the game in sort of mobile app pen testing, right? The other thing is, if you think about mobile devices are often overlooked. So if you're talking about scoping with someone, they might not think that the iPad or the tablet that they have in the meeting room, they might not consider that a risk. They might not even consider the risk that the phone that they're handling or that they have in their pocket, it's a risk. Or they might think it's a lower risk. Finally, we know that everything is moving to the cloud, and I think mobile devices are really no exception. There is a rise in the cloud-based MDM. So if you just Google, like, literally cloud-based MDM, you're going to get at least a dozen results of company offering these services. And if you think about it, if you find them in your recon and you get in, essentially, you basically own their mobile infrastructure. So what can you do with that? Let's see. So assuming you have a mobile app and you're doing a pen test or you're doing a red team, what are the main differences? Well, it sort of relates to the test itself. Essentially, as I briefly mentioned, doing a pen test, your goal is essentially to find as many issues as possible. So you might overlook something. In a red team, this is more specific. Your attack are more targeted towards the application and what's your end goal. So let's assume, for instance, that during a pen test, you find out that the application is storing data on the device securely, cookies being passwords, being whatever. From a red teamer perspective, not that helpful if you think about it, because essentially the scenario would be me going to an employee, punching him, I don't know, getting his phone, plug in this phone and get the information of the phone, pretty unlikely. So I might not get into how stuff is stored on the device. I don't probably care. Second point is sort of relates to the first one. So essentially, during a pen test, you do have limited time. And at the same time, you're trying to find as many issues as possible, remember. So you might flag an issue, being a secret injection, for instance, but you might not go ahead and actually test this further, see how far you can go. In a red team, this sort of doesn't apply. So you do have your deadline. You are going to have your deadline, of course. A red team engagement eventually is going to end. We're not real, I don't know, hackers. Well, we are, sort of. If you think about it, it's really up to you. It's the same thing as we're testing a web app, let's say. You find a secret injection. You want to try and get more out of it. So you do want to spend more time on it. And you do have resources when you're doing a red team, right? It's really up to you. So if you think that something is important, if you find a mobile app that, I don't know, maybe obfuscated, but you think that could be very interesting for your engagement, go ahead, spend more time on it. Finally, big thing, as I mentioned before, is the scope. For a mobile app penetration test, the scope is most likely going to be one APK, one IPA file that the client gives to you. And in some cases, as we know, most of the times, the mobile application basically is a web app that calls an API, essentially. And sometimes, during a pen test, because they want to focus so much on mobile app issues, they want to be compliant or whatever, they might even exclude from the scope the API endpoints, which is really bad, I think. During a red team, that doesn't happen. So the scope is the organization again. So essentially, you're not limited to the number of applications that you're testing. So if you go to the Play Store and you see that they have 5 applications, go ahead, download them all. It's all in your scope. If you reverse them, you see that the API endpoints is in scope. It's basically they own the infrastructure, or they own the server. Go ahead, test them. So assuming you have to do this, and you are on Android, let's say, there are a bunch of tools. They are well known, but you want to start and reverse the application. So a bunch of tools, you're probably familiar with this, but essentially you want to start and decompile the app with APK tool, pretty much the de facto standard. And then you want to get this to the source code. The way you do it is just run index to jar against the application, and then you open it with a Java editor, such as JDGUI. I'm a huge fan of JAX, I think that's how you pronounce it, but essentially it's pretty straightforward. It just takes the APK and gives you the code. It also has some deobfuscation capabilities, which might come in handy, because the app might be obfuscated. You can just throw a debugger at it, or reverse engineering tools such as Frida or R2, but with Android, I wouldn't really go that far. It's fairly straightforward to reverse it. You do have some tools or some framework, or scanners even, which can help you out to basically map the attack surface. So what can you do on the mobile app? Browser is one of them for Android. It's a Python tool, and essentially has a bunch of modules. So a module for scanning, even for finding SQL injection, or to find, I don't know, exposed activities, broadcast receivers, and things like that. Similarly, I'm a fan of this mobile security framework, or MobiSef. It's an open source project. It's essentially a web app, which you can give it your APK, and it's going to do some reversing, some scanning, essentially, and it's going to give you a result, which is a pretty nice looking report. And again, you're going to find issues such as insecure functions, exposed activities again, so it's just different ways of doing it. If you are on iOS, from a red teamer, I wouldn't really go and look into that far, because reversing is not as easy as Android, as you probably know. My best bet would be, if you really have to do this, just throw IDA or Hopper at it and hope for the best. There are frameworks here as well. If you follow the OS documentation or guidelines on mobile security, they have a bunch of references to Needle, which is, again, a framework which allows you to extract the keychain and things like that. MobiSef works as well, although I do think that you need the decrypted IPA, which, if you're a pen tester, not to worry about it. You can just ask them, saying that you need it for more value for the test or something like that. From a red teamer perspective, that would probably imply you compromising a development environment, or like a dev account or something. Pretty unlikely. So, okay, was this stuff actually helpful for us somehow? As I pulled you into introduction, yeah, it was. I want to propose two scenarios. So, in the first scenario number 1, we had a few things going on in our red team engagement. We did have, as part of our recon, a bunch of username and passwords. These were mainly from leaked databases, or again, information gathering, social media presence, and things like that. We also knew that the company was used Microsoft software. You might think, yeah, okay, 80% of them are using it, so what can you do with that? You want to enumerate as much as possible. And the reason is you can basically tailor your phishing campaigns toward the company. One of the phishing campaigns that we had running was essentially trying to gain access to their NTLM hashes by exploiting a known, let's not call it vulnerability, let's call it feature of Outlook, where essentially if you have a link to an SMB share in your email, and they enable the content of the email, they can potentially leak, according to their firewall maybe, they can potentially leak the NTLM hash to you. So you can go ahead and crack it offline and potentially use this combination of usernames and freshly new password cracked against other services. So, okay, we were pretty hyped because we managed to get the NTLM hash from phishing, and on top of that, we managed to crack it. So again, pretty hyped. We go ahead, we go to their mail portal, whatever they were using at the time, and sure enough, this happened. Password was wrong. So we thought, okay, what's wrong? We're pretty puzzled at the time because we did have other ways of verifying this password. We could, for instance, log in into their Skype. So we could see people online, we could potentially chat with people, but we could not log in elsewhere, like their mail portal. So again, pretty puzzled here. We were thinking of moving on, start another phishing campaign, maybe spamming people on Skype with links. Eventually, someone is going to open it. But eventually, one of my colleagues had an idea. So he thought, okay, let's go back. Let's think about it, right? They're probably blocking us somehow because people need to access their mail. So what are we doing wrong? We're coming from our systems, essentially. So there shouldn't be anything really weird, right? Because you want to have access to the email, as I said. But maybe let's try to get access through other means, other application. You probably guessed it. We try to access the mailbox from a mobile phone, from the mobile app. And sure enough, that worked. So essentially, it turns out that there were no restriction or policy in place from that prevented you from logging in. Basically, whoever logs in from a mobile app was fine. There were no restriction also in terms of where you could log in from. You know, we were doing stuff from our network. And on top of that, the main point was that these basically bypassed existing multi-factor authentication. So essentially, they had multi-factor, but they did not enforce this on mobile phones or anything that was coming from a mobile. It was pretty funny because, you know, we talked with this guy, the blue team, and they were like, oh yeah, how did you get around multi-factor? We were like, what multi-factor? You don't have it. So, you know, like, it was pretty funny at the time, but yeah, well, for us. For them, it must have been a nightmare. But essentially, you might have guessed, from there, we scrolled through the emails of this guy. Turns out that this guy is a very high-level employee, like very high in the chain. And basically, from there, if you're familiar with how Red Team should work, once you get access to an internal email, the other thing you can do is essentially you can launch an internal phishing campaign, which is pretty strong because it comes from a trusted source. On top of that, this guy was, again, pretty high, so people were sort of scared when they received the email from this guy, and they just went ahead and clicked it. So this phishing campaign had a few payloads in it, standard stuff that worked. So we start popping shell, and eventually move laterally, as explained, escalate our privileges eventually to domain admin, which was our goal at the time. So after a red team, there's going to be a lesson learned from both teams, right? So what did we learn? So if you're a red teamer, I would say do not ignore mobile devices or in general coming from another source when you're trying or verifying any sort of passwords. You never know. This stuff can happen. You can even bypass multi-factor. So even if you think that they have multi-factor, you do know that they have multi-factor, try from a phone. You know, it costs nothing. If you're a blue teamer, yeah, you have multi-factor, right? But try to enforce it properly. Review your policies, and when you do this, try to do not ignore your mobile devices. Think about that. Your employees do have one. So there was an example in which we exploited the lack of policies, essentially, on their devices. The second scenario, the scenario number 2, essentially we started this engagement, and similar to the first one, what did we have? Well, essentially nothing. So we started to look at mobile application as part of our recon. That's something that we decided because we were like, okay, maybe there's something more against this mobile world or whatever that we can exploit. So I started to look at mobile app during the recon phase, as I said. And because of the scope, again, is the organization. So I found at least 4 more applications that belong to the company. So this company are also like small companies, and those are all in scope, right? Because it's just one big company. So I went ahead and essentially give them a free pen test. Well, free, they paid for it, but anyway, like a pen test, essentially. I did identify, as I said at the beginning, general lack of application security, standard issues such as lack of SSL pinning. That essentially means that you can intercept the traffic fairly easily. And if they have an API, that's just like awesome, because you can just go ahead and test the API fairly easily. Bypassing the login page, not with SQL injection, just through the mobile app itself. So the way they were doing is they were exposing an activity in Android, which they shouldn't have. And you can basically bypass the login page by invoking this activity with a tool, essentially, browser if you want. They were storing data and security in the device, but as I said at the beginning, didn't care that much, because that was my device at the time. So I just moved ahead, and I decided to dig into the application more and to do some reversing. Main thing I was looking for was essentially passwords and API key. Of course, that would be, again, an easy win for me. I could just log in, and with the API key, probably get some password as well, or any access to the server. Usernames and email addresses, do not ignore this, even if you do not have a password, because you can just take them and use them across different services that they have. Even if they don't work, you still have something that you can use later on in the engagement. But funny thing that I noticed in mobile app, they use these sort of like dev email addresses that you don't find anywhere else. They just have like, I don't know, development@company.com, something like that. So that's a good way of, because probably they're not securing that account that much as their main account, hopefully for you. And then essentially, while reversing the code, as 2019, what I'm expecting to find, custom PHP code, right? So essentially, they have this API, which had, again, custom PHP code, which was easily exploitable. And sure enough, I did identify a few issues, being the first one, SQL injection. Cool. not that cool, great, but not that great for us at the time, because essentially the goal at the time for us was getting in, right? The database that we compromised was full of customer details, so we could potentially get names, email addresses, if they're not PCI compliant, probably credit cards and stuff like that, but we sort of moved on from there because it's not something that we were interested in. And then the next one was cross-scripting. Yeah, you might say, okay, what can you do with it? I would say do not really ignore cross-scripting when you do red teaming, because if you think about it, if you can do dodgy stuff from their domain and you send a phishing, you know, their mail filter might be super happy to accept their domain as a trusted link. But finally, more digging, being PHP, eventually you find arbitrary file upload. You might have guessed it, it's just an upload functionality, which again, all this stuff was given me from the mobile app. I didn't fuzz the API or anything, it was just the mobile app in the code was telling me, look, this is how you use it, and yeah, that worked essentially. So the way you concluded the engagement was you go ahead and you upload a PHP shell, super easy. Although we kind of hit a wall there because the box that we compromised was essentially just an Azure box somewhere. It wasn't really connected to their internal network. So the thing with this engagement, you get super hyped, and then you get basically down, and then you get hyped again. So, so from this compromised box, though, we did more digging, and we found clear text credentials embedded in a script. We could reuse them across another service. We did that, and then we got blocked again by their SOC or whatever they were using, because essentially we were trying this. It's probably a mistake, lesson learned. We tried this from our infrastructure. Turns out, we could actually use this box as an attacking / pivot point. So we could essentially use this box to authenticate on other services, and whatever approach they were using, they were not blocking us. So it was probably a whitelisting approach based on IP addresses. So yeah, because that IP was trusted, even though it was just a random dev box on Azure, it was completely fine. So eventually, from there, got VPN access and compromised the internal network, which again was our goal at the time. So lesson learned, what are the takeaways from this engagement? Well, as a red teamer, I would definitely now include reversing or having a look at the mobile application as part of my recon now, because you never know what you're going to find. That API endpoint, you're probably familiar with the recon process, but there are a bunch of tools to enumerate domain names, Amos, GoBuster, you name it. That domain name wasn't flagged by any of this because it was like so random, and it was probably used by just that mobile app that, yeah, you probably wouldn't find it with these tools. So if you're a red teamer, start looking at the mobile app. As a blue teamer, you want to protect your mobile app, so harden it, get a pen test, and please include the API server in your pen test. That's probably the main thing that your mobile app is doing nowadays. So that made me think, okay, we started basically exploiting a lack of policies, and then mobile application, what can we do on this mobile stuff, right? We could eventually maybe target the mobile user itself. Can we do this? Most likely, if you think that on the Play Store, as you're probably aware, it's full of malware. Google is trying its best, but still full of malware. But from a red teamer perspective, it's sort of a gray area. If you think about it, when you put stuff on the Play Store, you're still agreeing with terms and conditions of Google, and Google is not very nice with red teamer, if there are some article out there. But essentially, yeah, do your research before you start targeting people this way. As I said earlier, MDM are also an option. So if they have one in the cloud, if they use this service, if they have one exposed in general, you might just have default creds or weak creds, and you can just get into the MDM and push stuff onto the device. That's another way of, another vector, I'd say. Finally, you can just send the APK, email, SMS, if you have the number. You might argue that this requires a huge amount of user interaction. I tried myself, in Android it's crazy, you need to enable an option and things like that. But to be fair, I don't know you, but every time I look at friends and family member, they have malware, sure enough, you go into their download folder and they have some random APK from like somewhere that they downloaded. I don't know how they managed to do it, but if they can manage, if you have a good pretext, which is not just watch this video, although it might work, yeah, you might get into them into installing your application. So assuming you have one method, being one of them, being another method, to deploy something onto a device, what are you going to deploy? You might be aware that out there is a meterpreter.apk. Meterpreter is well known. It's a Metasploit payload, essentially. You can generate it pretty easily with one liner of MS Venom. But do you really want to do this? You might argue, again, no one does have an antivirus on their mobile phone. I might say, yeah, you probably don't. You're dealing, most likely, with corporate phones. Most of the times, antivirus solution, they do come with MDM. Also, the other way around. If you have an antivirus, they might come with an MDM to manage it. So you don't want to spoil it just because you want to drop Meterpreter on it. So, okay, what are we going to do? Well, we do have existing tools for this. We're pen testers. We do have sort of offensive toolkit, right? So why not exploiting this? So here's where Frida comes into play, or could come into play, I think. So actually, quick question. How many of you heard of Frida, are familiar with it? Okay, quite a few. Good. Yeah, I wouldn't be surprised if you are familiar with it. In the past years, I'd say. It's been pretty popular in mobile app pen testing. If you're not familiar with it, essentially, Frida is a dynamic code instrumentation toolkit, which allows you to inject JavaScript code into native apps for a bunch of platforms, including our mobile platforms, such as iOS or Android. So why Frida is so popular nowadays is essentially in pen testing allows you to do a bunch of tasks that in the past they were kind of tedious. Think about these functions, right? SSL pinning bypass or root detection bypass. Before Frida came in, you basically had to decompile the APK, find the function responsible for it, sort of change the functionality, put it back in, repackage the APK, push into the device, pray, and hopefully that's going to work. Now, with Frida, it's essentially just a matter of loading a script, and these scripts are even universal. So no matter what library they're using, they're kind of advanced, and they can recognize the library and do the SSL pinning for you. Same thing with root detection. So how this thing works is essentially Frida is looking for a function being is device rooted, return true or false. Of course, if your device is rooted and if the behavior is correct, it's going to return true at the question, is the device rooted, or to the function. The way this Frida JavaScript hooking works is essentially you just hook the function, wait for it to be called by the device, by the application itself, and it basically returns false no matter what. So your application doesn't care if the device is rooted anymore because you can just load a JavaScript which tells to the app, okay, just return false to the function. I don't care, whatever you want. I like the other functionalities such as memory dumping. So there is a tool called FreeDump that you can use. This is essentially dumping the memory of the process, which in this case, if you're looking at a mobile app, that would be your basic application memory. And it's helpful because if you think about it and the device, it's the application is stored, everything securely on the device, they might leak stuff on the memory. So what you do, you basically dump all the memory, and you go hunting in memory for passwords, creds, username, whatever you need. The last one, the runtime decryption, it's sort of a CTF-like thingy, but I added in 1 or 2 engagements where it was helpful. So essentially, if the application is doing some encryption, instead of you going there, reversing the app, of course you want to save some time. So what you can do is just waiting for the application to invoke the decrypted value or even the function, and just hijack this function and print the decrypted value for you. It's pretty straightforward, but again, fairly used in CTFs. So, as I said, I want to propose Frida from a different perspective. So maybe can we use as an attacking toolkit? Can we maybe create a backdoor with it? It is possible. It's even well documented. Essentially, they have this Frida gadget library, which allows you to run the Frida, essentially, on the device, even if the device is not rooted or jailbroken, which is pretty likely if you're doing a red team engagement, you're probably not going to be dealing with a rooted or a jailbroken device, right? The process kind of follows these steps. So you want to start by decompiling the application. decompiling the APK, if you're under Android, it's pretty straightforward. You just use APK tool. What you want to do then is injecting the gadget into the APK. So you do have your unpackaged APK. You download the library, you put it in the lib folder, and the library is there at the moment, but it's not invoked. This is where the third step comes in, which is editing the smiley code, or essentially the application code, in a way that as soon as you open the app, the Frida library will be loaded. So you probably what you want to do is look for the constructor and put your invocation for Frida in the constructor. So as soon as the app is open, you have Frida, essentially. Fourth step, essentially, is the final step, which is creating your APK again. Again, APK tool is just creating the APK for you. But, you know, being lazy, there are other ways that you can do it automatically. If you're a pen tester, you would call this process patching an APK rather than backdooring. I think that's the same. I'm a huge fan of Objection. This is a framework. It's basically a Python framework built around Frida, on top of Frida. And it's pretty straightforward to do this process. It's just one command, patch APK or patch APA, depending on the platform. There are other scripts out there that do this for you on GitHub, freely available. I had some luck with this Frida leaf injector. But personally, when Objection fails, I would just go back to the manual way, because if you go back to the stages, your main point of failure here with Objection is going to be your first and fourth stage, so the APK tool commands, because there are some custom flags that you can specify, so you have a bit more control on the manual process. So if the application is using some weird resources and Objection cannot repackage the APK, just do it manually. It's not a long process, but you know, if Objection is there and it works, why not just using it? So as we said, how can we do something malicious? As we said, it's basically a framework. Frida is basically a framework that allows you to inject JavaScript. So, and there are already existing scripts, which I think we can slightly alter to change the behavior of the application in a more offensive way, as I said. Take the following example, for instance. This is JavaScript/Java/Frida code, which originally, what this script was doing was waiting for a web view. A web view, if you don't know, is essentially an embedded browser in Android. You know, sometimes you might have looked at it. You know, if you scroll on up and you open something, you click a link, it doesn't open your Chrome. You know, it opens like a weird browser-looking window. That's essentially a web view. So what this script was doing was waiting for a web view to be called and print the value of the URL that the web view was loading. That was pretty helpful. You know, if you cannot intercept the traffic, you can just look at what URL the application is loading without doing SSL pinning bypass and things like that. But the other thing you can do, you can probably do this. You can just specify an arbitrary site, arbitrary website, in a variable or whatever. And yeah, you can wait for the web view to be loaded, but you can also override the behavior of the web view. So you have, you know, standard web view, a function which is used to load a URL, which is called load URL. So the way you do this is just overload the load URL function, the call of this function, which an arbitrary value, which in this case is going to be this variable, the k variable, and that k variable is going to contain the attacker website or your website. So essentially, the way this is going to work, this web view hijacking, you might have guessed it, but essentially, what you're going to end up with is a scenario like this. So you try to connect with Frida. Nothing happens, right? Because my app is not open. But as soon as I open the app, you do have a Frida gadget there, which is essentially mean that now Frida is running and loaded on the device, so you can interact with it. So what you can do is maybe load Objection. Again, it's the framework that I mentioned earlier. It has a few cool functionalities, such as operating system command. And the way I import my script is just import my script with the web view hijack.js. Very straightforward. Now, nothing is happening on my device when I do import script. Reason being because the device is not calling any web view at the moment. It's just working with their activities. But sure enough, as soon as I click the sign in, the application is actually loading a web view, which I can hijack, and hopefully, well, it's a video, I know it's going to happen, but there is my nicely looking phishing page. And as you might have guessed, on the bottom left, I'm essentially waiting for this guy, which is me, but yeah, anyway, this guy to insert his creds, and I can capture them. And the application flow, important, is not interrupted, so the user has no clue what's just happened. So this is essentially how can I hijack a web view. It's very easy. As you saw, the code is pretty much, 5 lines of code. And I just closed my demo file. Sorry, just for later, it's easier. So, okay, that was an example, right? But some of you may already spotted a small issue, which is this attack at the moment is working locally. So I was connecting to a device on a 10.something address, which is a local address, on my local network. And this is default Frida gadget behavior. But there is a way to automate this and to get around it. So what you want to end up with, essentially, if you want to create a backdoor, is something that you can run, that it runs, actually, as soon as the application is loaded and requires no further interaction from you. You know, I don't need to know that Frida is running. I don't need to interact with it. I just want the script to run, and that's it. You can do it by using config files. And a config file is very complex. No, I'm joking. It's just these like 5 lines. It's pretty straightforward. By default, as I said, the behavior is to listen. So the type will be listen. So, but we can just override this by saying type script, which, you guessed it, is just loading a script. And that's going to be defined by the path variable, which is the path to your script. And the onload resume is just so that the application doesn't stop, because again, the default behavior is to wait an application, to wait for your script to be finished for the application to continue its functionality, essentially. So if you do this, it's basically overriding this behavior, and basically it's done because the user doesn't need to wait, right? We want the users to continue using the app. There are a few hacks that we need to remember when we use a config file. First is how you call the config file. The standard says that you need to call this file with the same name of the Frida library, .config.so. If you're using objection, you're probably going to end up with a naming convention like this one. So libfrida-gadget.so is going to be your Frida gadget library, and your config file needs to be named libfrida-gadget.config.so. The other thing is that if you think about it, if you don't have a phone with you, or that's your target, you don't have control over the path variable, right? So if we go to the script, your path variable, if you're a pen tester, you can just plug in the phone, put the script into data local temp, and say to this gadget config, okay, load the script from data local temp myscript.javascript. You don't have the luxury of doing it here. You don't really have control over the path. So because especially if you try to put a JavaScript file in the library folder and you repackage the APK, that's fine, it's going to be there. But as soon as you install it, the Android operating system is just going to get rid for you, of this for you very nicely. However, I did find that in a similar way of the previous point, Android is going to preserve whatever config file you have for an existing library. So you can sort of hack this by saying you have a library which is called libssl.so. I don't care about what this library does. It's probably going to do SSL stuff. But essentially, you can rename your JavaScript file to be something like libssl.config.so. And Android, not knowing how a config file is probably going to looking, is just going to accept this, and it's going to save it when the application is installed on your device. So you probably want to end up with something like this. Frida config is in red. Just below it, it's the original gadget.so, which is the library. So you just call it, as I said, .config.so, and that is to load your Frida. And then I just picked a random library, like this libglog.so, which is below the green box. And again, I don't care what this library does. I just need a name for my JavaScript. So I just named my JavaScript libglog.config.so and told to my config, grab the JavaScript from this config, which is not a config, from this file. So all of this is done so we can automate the process. So fairly similar demo, but essentially, as you can see now, locally, I don't see any Frida anymore because my type is script, it's not listen. So I can't see any gadget here. But I don't care because if the backdoor worked, my script is already loaded in the APK well, in the application that's installed on the device. So essentially, as soon as I click the sign in button, as we saw before, the phishing page is loaded, and I didn't need to interact with the application whatsoever. And this works even not on the local network because the script is there, and I capture creds, and the application flow continues. So, okay, we saw that we can maybe orchestrate or instrumentate the application in a way so that loads something malicious, I'd say. Maybe you can use for capture credentials, but can we get some sort of execution on the phone using Frida? Ironically, you already can. If you're a pen tester and you play with objection, you already know that recently there's been a release that included a plugin to load Metal on iOS devices. Metal is essentially a stageless meterpreter shell. So it's a smaller meterpreter which works for embedded devices, which are our phones, right? And yeah, the way you can do this with Android, so what I wanted to do, I wanted to port it to Android. And while I was doing it, Frida released the C module, which essentially loads C code on runtime with Frida, so with JavaScript. And if you think about it, C code gives you access to the system function. So you basically can ultimately store Metal as a fake config or meterpreter or whatever, and load meterpreter through JavaScript through Frida using C code. And if you're using objection, you're even using that on top of Python. So bit of mess, but essentially, as I said, you can store your meterpreter as a config.so. Android won't care. It's just a file for Android. You need the full path, because when you invoke the C code, it doesn't understand your relative path, so you need the full path. You can extract it with Frida, again, fairly easily in this way. So you just get the context of the app, and then you get the package resource path, which is going to be something like this on your device. By the way, I'm using OneDrive just because it's random. You can do it with any application that can be patched, which is essentially everything. And yeah, then you need your architecture. I was using an emulator, so it's x86, but I tested on my ARM devices, and they worked fine. And then you essentially know that Metal is going to be there. So you basically load this script, and you have the path variable that you can invoke. The way you load C code is, again, very complicated. It's just like one big string of C code in JavaScript, which you can just include standard libraries, and then you invoke the system function, as I said. And I'm invoking this weird libssl.config.so, but essentially that's your Metal/meterpreter/ any binary that you can drop on Android. And the C module is going to do the difficult job for me. It's just going to load the code on runtime and execute it with the last function. So I'll show you quickly how it works. Again, all automated. I'm already backdooring the app. I just want a meterpreter shell now. No session on my Metasploit, but as soon as I open OneDrive, I should get a meterpreter shell. And just confirming that I'm on my Linux host, which is Genymotion, is an Android emulator. And then from here, I can execute a system function. Funny thing about meterpreter, it took me a while to figure it out that when you do shell, it's looking for bin.sh on a Linux on a Linux binary. But because Android stores stuff in the system bin.sh, that gives you an error. So I thought that this wasn't working for about a week. But essentially, the way you do it is just you execute system bin shell, which is where the shell is, and you interact with it. So you have an Android shell, essentially. Small caveat, this is basically linked to the permission or to the context of the application. So you can do what the application can do. So if the application has permission for getting your location, you can get your location. If the permission doesn't have permission, if the application doesn't have permission to take photos, you're not going to get photos, unless you change the Android manifest before package the APK. But I would say if you have to do this, don't change things too much, because otherwise it sounds dodgy, and you don't want to do that. So work with what you have. Most of the times, application got a lot of permission. So that sort of concludes my talk. I just wanted to recap a few things. If you're a teamer, again, mobiles are not to be overlooked. So include looking at mobile apps in your recon phase, and think about their policies. Could be very relaxed in terms of mobile app or mobile devices. If you're a blue teamer, same thing. Do not ignore your mobile infrastructure, but from a defensive perspective, of course. So harden your mobile app. Look into maybe some anti-reversing tools. There are a few out there, but essentially you don't want to store sensitive information in the code in the first place. Finally, I do think that Frida can be used as an offensive toolkit rather than a pen testing toolkit, because if you think about it, there are already pre-made scripts for it, which can slightly be adjusted, like the WebUI Jack that I showed today. There are already powerful frameworks like Objection that essentially has functionality such as download files, load files, execute a brain system command, and this sounds like a remote access toolkit to me, essentially. So I think there is a potential for an entire command and control on mobile infrastructure, which is entirely built on Frida. So the concept is you basically backdoor an application with a massive JavaScript file, which basically gets a shell to the attacker, and potentially, yeah, that's how you can backdoor the infrastructure or use them to move laterally to grab credentials, as I showed with the fake login page, and so forth, so on and so forth. So yeah, that concludes my presentation. Thank you, everyone, for listening, and if there is any question, happy to help. Thank you.
Are there any questions?
Congrats for the presentation.
Thank you.
You mentioned many of tools and methods, and thank you for that, which nowadays may work, but not sure in the future. Maybe all of the company or vendors will enhance their application. So my question, do you have like a research team behind which is testing all of these or trying to find other methods and tools to be in line?
Yeah,
with
you need to keep an eye on them, because as you said, some of them might be broken in the future. Let's think about iOS. You know, the keychain is pretty difficult to dump, probably impossible. So you need to keep an eye on it. But I think in the long run, you might end up doing essentially your test on Frida, because it's pretty difficult, because it basically runs on runtime, right? So even if the device itself is protecting you from doing things, the application is running. So if you can control the runtime, it doesn't matter what the app is doing, you can see whatever. So I do think that in the future, not every tool, but most likely, most of them are going to build around Frida. So I'd say, yeah, keep an eye on the tool, but work on Frida if you can, because that's essentially the future, if we want to call it that way.
Thank you very much.
All right.
Hey, what are the most common security flaws you find on mobile devices?
The most common vulnerabilities.
Vulnerabilities or security flaws?
Okay, for mobile devices or mobile applications, sorry?
For mobile devices.
Devices itself. Well, I've looked at a few MDMs, and I would say the fact that, first of all, there is no control about what you can install on the device itself. So ideally, you want to have a restricted Play Store, if that makes sense. So, you know, the company is using just a few applications, right? So why do you need random employees to install stuff from the Play Store? So the main thing, I'd say, is restricting the user, the end user, from installing random things from the Play Store. I'll say, yeah, that's the first thing. And then standard thing that do apply to workstations, such as passwords, you know, they might allow you to put a PIN. We all know that's vulnerable. So, you know, you want to enforce password policies or fingerprinting if you accept the risk. So, yeah, I'd say those are the main vulnerabilities or issues. Yeah.
One more question.
Hi, thank you very much for your presentation. It's very, very interesting. My question is, have you ever had a problem with the penetration testing going wrong, and what did you do about that, and how the blue team reacted?
Okay, going wrong.
I'm thinking about maybe some malicious virus, something malicious being in the system after the penetration testing or something like that.
Yeah, I did.
It's very important.
Yeah, no, I did have once where essentially there was a very critical system that, yeah, it's that story. So essentially, there was a SQL injection in the login page, more specifically in the update or forgotten password functionality. Again, very excited about it, didn't think about it, and I just basically did a forgot password, and I set for the username or while equal to 1 a password of password. Now, if it's a SQL injection, you're probably going to end up with insert into database for the user or 1 equal to 1, which is every user, password equal password. So I basically reset the entire database to password equal password. And funny thing, after 3 seconds, people are going to receive calls, and they're going to say the word ransomware around you. And you know, they thought there was a ransomware, and I was just there sweating, waiting for the police. So yeah, that was a funny day.
Okay, thank you.
No worries.
Thank you very much for your presentation. This
All right.
was really fun.
All right, thank you. Thanks, everyone.